We are in section 5.5, which is very last section of this semester, okay? So we are here now, okay? It is substitution rule, and in general, we're gonna say it is use of, because we're gonna use U notation a lot for here, okay? But like it's not a like formal name, but formal name is the substitution rule, but like we simply say use of, okay? So, well guys, this is a really important thing for next course, okay? When you take calculus 2, you will start from here, and your instructor will assume you know about this one, okay? So now we're gonna practice this one, okay? Here we go. So basically, like, use of case, so we're gonna like look at your function. It is f of g of x times g prime dx form. That's exactly chain rule form. Is that okay? Then look at that. Your g is inside function, and in my class I keep saying t-shirt function, right? And then your t-shirt function is in there inside of the jacket function f. Then you have to multiply t-shirt function prime. Is that okay? Once you find like this form, then you can use the substitution rule. Okay, you can just simplify like this way. Okay, so it might better to talk about this one with the example. Okay, just come follow me. Okay, here we go. So look at that. So can you find your t-shirt function, t-shirt function prime? Can you? Here we go. X to the 4 plus 2. If I assume this is your t-shirt function, then we know x to the 4 prime will be something x cubed. Actually, it's 4x cubed, right? So there is x cubed term outside, but unfortunately, like the coefficient is different, okay? But it's doable, right? We can just handle the coefficient, okay? So now let me show you how we can use the use of to evaluate the antiderivative or indefinite integral of your function, okay? So here we go. So now let me do the pre-step first, okay? The pre-step is like this way. Let me define new variable u. That's why the nickname of this one is u sub, okay? And u is x to the 4 plus 2, okay? Second step is we're gonna take the derivative with respect to x, okay? Then your left-hand side will be du over dx, and right-hand side will be 4x cubed, right? And I believe you learned about differentials, right? Then we can consider dx as the one variable or one value. Then we can multiply dx on both sides. Then this can be written by du is equal to 4x cubed dx. Are you with me so far? Okay, step 3 for pre-step. I'm going to divide by coefficient 4 on both sides. Then this will be 1/4 du is equal to x cubed times dx. These are pre-step, okay? Now we are ready, okay? Now what are you going to do is we're going to do the puzzle, okay? So let me tell you what that is, okay? So this indefinite integral itself is the puzzle, okay? And also we have all the pieces. First of all, we have first piece u, okay? So what I want to say is this guy, x to the 4 plus 2, will be replaced by u, okay? The second piece is on the bottom, okay? Now we're going to replace your x cubed dx with 1/4 du. Can you find it? There we go. X cubed and dx. This guy, okay? That guy will be replaced by 1/4 du. Okay? Simple puzzle, right? Now, let me rewrite this indefinite integral in terms of u, okay? So that is equal to integral cosine u and 1/4 du. Nothing else, right? So let me write 1/4 in front of the integral, okay? Wow, wow, wow. You see? That's really simple in antiderivative, right? So it is equal to 1/4 sine u and constant c, right? Once you are here, we're going to replace your u with x to the 4 plus 2, right? So the answer is 1/4 sine x to the 4 plus 2 plus c. This is substitution rule or use of technique. Let me give you a couple of more problem, okay? So these are the use of problem, okay? Or we can say substitution rule. That is the formal name, okay? But like, in general, we can say use of, okay? So can you find it? So first of all, we need couple of pre-step, and let's do first, okay? Here we go. So the first one is we're going to define u. Then you can easily realize that your u will be the under the square root, okay? Which is 1 minus 4x squared, right? And second step is take the derivative. du is negative 8x and dx now, right? As I explained, like dx was here, but I just multiplied, right? And then the third step is we're going to divide by negative 8 on both sides. Then this will be negative 1 over 8 du is x dx. Is that clear? Now we are ready. Let's do the puzzle, okay? So let's come back to the problem. So first of all, 1 minus 4x. This part we define with new variable u, right? It is u. The second one, the very last one, x times dx can be replaced by negative 1 over 8 du, right? Can you find it? There we go. X. I'm talking about this side, okay? So that will be replaced by negative 1 over 8 du. Now, there's no more x term in there, okay? So now let me rewrite my indefinite integral 1 over the square root of u and 1 over 8, negative 1 over 8 du, right? Let me write negative 1 over 8 in front of the integral, okay? It's negative 1 over 8 integral 1 over square root of u du, right? So that's it. Like this is simple antiderivative, right? So like let me try to write this one as a power form. It is equal to negative 1 over 8 integral u to the negative 1/2 du. Let me move back here, okay? It is equal to negative 1 over 8, and then by the power rule, right? 1 over negative 1/2 plus 1, and u to the negative 1/2 plus 1, and don't forget the constant c. Simplify. Negative 1 over 8 times 1 over 1/2 u to the 1/2 plus c. Then this one is what? Is 1 over 1/2 is 2, right? 1 over 8 times 2 is negative 1/4. Negative 1/4. And u to the 1/2 is square root of u. Almost there. Once you get here, then we have to place back your u with 1 minus 4x squared, okay? So your final answer is negative 1/4 and the square root of 1 minus 4x squared plus c, okay? So one more time. Like this chapter is really good, right? So whenever you get the answer, you can double check, okay? Just take the derivative with respect to x for this one. That must be inside of integral, okay? That is really good thing, okay? And now let's talk about c. Well, we know integral of sine and we know integral of cosine. Then we assume we know integral of tangent. But you know what? It is wrong, okay? Well, you can memorize it as a formula, but like, this one can be found by the use of. Let me show it to you, okay? Here we go. So let me rewrite this one in terms of sine and cosine. So since tangent x is sine x over cosine x, this can be written by okay? Then we need pre-step to use the use of, right? Here we go. So first of all, let me define your variable u as cosine x, which is denominator, okay? The next step, same thing. Take the derivative, right? du is cosine prime is minus sine x dx. And let me multiply negative or divide by negative 1 on both sides. Then I can say minus du is sine x and dx. Now we're ready. Now it's time to do the puzzle. Here we go. So we define cosine x as u. And then we find sine x dx can be replaced by minus du. Then we're done, right? So that is equal to integral 1 over du and minus du. Let me write the minus in front of this, okay? It is equal to minus integral 1 over u du. What is this? It is natural log, right? ln, negative ln absolute value of u and plus c, right? Then it is time to replace back with cosine x, right? So finally, it is equal to minus ln absolute value of cosine x plus c. This is indefinite integral of your tangent function.